Hi all, welcome again to new topic and it's about capacitor and dielectrics. The topic involving three sections. For 2.1, capacitance and capacitors in series and parallel. 2.2, charging and discharging of capacitors. And 2.3, capacitors with dielectrics. What is meant by capacitor? A capacitor, sometimes called a condenser, is a device that can store electric charge. Define capacitance. It is the ratio of the charge on either plate to the potential difference between them. Or we can define by using the formula where C equals to Q over V. Q is a charge on one of the plates. V is a potential difference across the two plates, meaning that the ability of a capacitor to store charge is measured by its capacitance. One remark here, capacitance measures the charge on the capacitor for unit voltages across it. Define 1 farad. 1 farad is equals to 1 coulomb per unit 1 volt, or 1 farad is the capacitance of a capacitor if the charge on either of the plates is 1 coulomb when the potential difference across the capacitor is 1 volt. When C is constant, then the charges stored Q is directly proportional to the potential difference V across the conducting plate. Unit SI for capacitance is coulomb per volt, or equals to farad, or equals to F. This is the electrical symbol for a capacitor. Can be these two, but this one is a common one. Capacitance or the capacitor of a parallel plate can be written like this, where C equals to epsilon naught times A per unit D, which is equals to Q over V. So mathematically, the capacitance of a parallel plate capacitor is proportional to the area A of its plates and inversely proportional to the plate separation D. From the given formula, epsilon naught is permittivity of free space, which is equals to 8.85 times 10 to power of negative 12 coulomb square per Newton per meter square or farad per meter. A is the area of the plate, D is the distance between the two plates. Let us try to attempt these A-level questions. The plates of a parallel plate capacitor area 8.0 mm apart and each has an area of 4.0 cm square. The plates are in vacuum. If the potential difference across the plates is 2.0 kV, determine A, the capacitance of the capacitor. B, the amount of charge on each plate. C, the electric field strength was produced. These are the given values in the question, where A is area, which is equals to 4.0 centimeter square, equals to 4.0 times 10 to power of negative 4 meter square. V is a potential difference across the plates, which is 2.0 kilovolt, equals to 2.0 times 10 to power of 3 volt. D is the distance between the two plates, equals to 8 millimeter, or equals to 8.0 times 10 to power of negative 3 meter. And constant value of permittivity of free space, which is equals to 8.85 times 10 to power of negative 12 farad per meter. This is a solution for A, where C equals to epsilon naught times A per unit D. We are going to substitute all the values accordingly into this formula to get the capacitance of the capacitor, which is equals to 0.44 picofarad, or 4.425 times 10 to power of negative 13 farad. For section B, determine the amount of charge on each plate. We can relate these two formulas to get the answer, where C equals to Q over V. Substitute all the possible values into the formula to get the amount of charge on each plate, which is equals to 8.8 times 10 to power of negative 10 coulomb. Finally, for section C, determine the electric field strength was produced. Electric field strength between two parallel plates E equals to V per unit D. We're going to substitute all the possible values into this formula to get the electric field strength, which is equals to 2.50 times 10 to power of 5 volt per meter. Simple like a bubble without giving you any trouble. Thank you for watching this video. Thanks a lot, and thank you to the Lord.